Hey, and welcome to the part 8 in this video series about Echinoidea, a pavilion built in Milan in Italy, 2022. We have 2 sticks left to move from grasshopper to BIM objects in Revit, and that's these 2 light red sticks. These sticks are a little bit special. We are going to use sweep path to construct the joints, but we have to calculate the path, and that's because we have upper side of the joint that cuts through the whole stick and lower side of the joint that doesn't cut through the whole stick. And as you remember, we define parameters in relation to the sweep path, and our sweep path is going to be this line, and we have to calculate the x value, and we are going to use a simple Pythagoras in order to calculate the x value, and then our path is going to be x plus a, and a value we can read from Rhino. X we are going to calculate, and then x plus a we are going to push to Revit in order to construct the joint. I'm sure you know Pythagoras. If you don't, if you need to remind yourself, just go to Google and you will find a lot of information about the Pythagoras. Let's make a family first. We go to Revit, File, New, Family. Okay, I save the project. English, and we used column family, metric column family. Let's start. Let's change first these dimensions, 200 by 100, easier to go here to family types and properties and change 100, okay, create, extrusion, take this rectangle, okay, check, and let's go to the back view. We are going to construct our joint on the back view, and the extrusion height we are going to connect to a parameter that we called cutting length. New, shared parameter, instance level, select, cutting length, okay, and we will make this a little bit higher so that we have place for our joint. And now I'm going to sketch the joint according to this sketch. And let's see, create model line, offset 100. Then we have a line that goes from this lower side, trim, this is going to be our path. Now we will create the profile. I go to the plan view and I will construct a new reference plane that is 20 millimeters from this back reference plane. That's because the depth of our joints is 20 millimeters. Let's see, create reference plane. Let's see the distance. Delete, and I will call this plane joint. Let's go to the back view and create new model line, but before I do that I will set the work plane to joint. Okay, and now I will draw a line, and let's go to the 3D view. And now I have my second line that's going to be the part of my profile. Go to the back view and create. Now we will create our joint using sweep void. And as you remember, we have to use sketch path and not pick path. If we use pick path, then we are not going to be able to define parameters. So use sketch path. Now I have my path. Check, modify. And now we can access this edit profile tool. We are going to go to the 3D view, open view. And I will pick those two lines that I sketched. Now actually I draw my path on the joint reference plane. I don't want that. Go back to the back view and create, and I will set my work plane to back. Reference plane back. Okay. And now we can go to void sweep. Sketch path. Okay, check, press modify, add profile, go to the 3D view, pick the lines and draw other two lines. This one, that wasn't correct. Okay. Enter. Now we have our joint. It looks like this. I will erase detail lines. Let's go and define the parameters. Go to the back view, edit sweep, and choose the path and edit sketch. Since we use sketch path and we didn't use pick path, we can access this edit sketch button. If you use pick path instead, then you will not be able to access this edit sketch button. And we need the edit sketch button in order to define the parameters. As you know, you define parameters to sweep void in relation to the sweep path. And let's define the position of the joint, angle of the joint. Let's see, do we have something else that we need here? No, that's those two dimensions that we need. Oh, actually, we need the length of the path. Let's define that parameter as well. Choose the dimension, press create parameter button, shared parameter, instance level, and we already have cutting length parameter since before. Okay. Oh no, that's not the cutting length, that's L1. The position of the joint is this parameter L1. Cutting length is the length of the whole stick. Let's define the angle of the joint. Choose the dimension, go to the create parameter button, shared parameter, instance level, select A1. And this one, carpenters do not need this parameter in order to produce the stick. But we need this parameter in order to construct the stick in Revit. We are going to define reporting parameter, this length. That's the length that a carpenter needs in order to produce this stick. So I'm going to create a new parameter that I'm not going to have in my schedule. In my schedule, I'm only going to have the parameters that the carpenter needs in order to produce these joints and sticks. So I need to define a new parameter. We call it LPath calc, calculated path. Okay. Okay. Choose this one. Okay. Now I have that parameter. I'm not going to have it in my schedules. In my schedules, I'm going to have this length. I cannot define that parameter here because all parameters in sweep void are supposed to be defined in relation to the path. Okay, I'm happy with my sweep void parameters. And now I'm going to create a reporting parameter for this length here. And let's go to dimension. And I choose this line to this point. I will create a new parameter. Shared instance, select, edit. New parameter, length, and I will call it L joint 1. Okay, Okay, and joint 1, and that's going to be a reporting parameter. So let's see our parameters here. This reporting parameter is grayed out. We are not going to be able to change it in Revit at all. All the other parameters we can access in Revit and change, but not the reporting parameter. And now I have my family. I didn't save it, I see here. I will save it. This one is going to be stick 4. The last one was stick 3, so this one is going to be stick 4. Save. And I will load this family type in my project. Escape. And now we can go back to Rhino and Grasshopper. First we need our location lines, and the location lines I have here, the lines. I will take the list item component, move it here close to the breps that we are going to work with, and copy this list. Copy the yellow panel, but these lines in this component do not correspond to these breps, so I have to change in the list. I think the index values for lines are 35 and 36. I'm not sure. Let's see. Yeah, now I have the right lines. And let's go to Revit menu in Grasshopper, choose Add Column component, and this component wants location. The location is our lines. Now you see we have these sticks in Revit. The cutting length is not correct, so we need the information about the cutting length, and the cutting length is equal to the length of the location lines. Let's go to Curves menu and Analysis, Length. Let's see the length. It's stored as a group. I think we need to draft this information. That's not what we are going to do. We need to change the type to the stick 4. That's correct now. And then we go to the Revit menu and take element parameter as we did before, and connect the column to the element. We need the parameter name. That's cutting length. I have it somewhere here. And now I go to Curve menu, Length, read the length. Let's see the information. It's stored as a group, and that's why we are going to draft the information, and now we can connect it to this element parameter. Let's see. No, obviously we don't need to draft the information. The length is correct if we go to Revit and choose one of the sticks and check cutting length. Cutting length for this stick is 2051.6. Cutting length for the next stick is 2162.7. The cutting length is correct. Let's organize this a little bit. Now we can extract the information about the position of the joints. We go first to surface, deconstruct brep, and let's read the edges. We need this edge and this edge plus this edge and plus this edge in order to position the joint at the right height. And let's see, I go to list item, connect edges to the list input value, take a slider. I think we have 26 edges here. And basically, I did this before, so I didn't show you that you need to check if the information for both of the sticks is the same. You can do it like this. If we hover over this E output value, we see that both sticks consist of 27 edges, so the information is the same. I mean, this edge and this edge are going to have the same index value. So let's go and see what's the index value of these two edges. I will just turn off this component and I can keep this one. Index value 11. I will store that value in a yellow panel so that we don't change the index value by chance or accidentally. And let's copy this component. Now I want this edge and this edge. It's 22. Copy this yellow panel and change the value to 22. And let's go to the curve menu and choose length and math. The position of the joint is going to be this length plus this length. And I go to Revit menu again and bring element parameter again. And the element is this column. Parameter, I think it's called L1. Copy this. Bring it down here. And let's see, take this stick and L1 is 1369 and the next one has the same, so that's not correct. Let's read the information for the column. See, it's not the same information. So this is one group, columns are one group, and the output for this result length are two individual objects. So I flatten this result, and now the information is the same level. And let's see. The height of this joint is 1369 and the height of the next joint is 1545.5, so that's correct. Now we are going to construct the path. To calculate the path according to this sketch, maybe I can organize this a little bit. Let's copy the list item. And let's see what we need here in order to calculate the path. We need this A value. And let's find that line, that edge. That's this one. Copy this panel and write 17. Take the scribble, write here A. And let's group this. I need B and C as well. Let's see B value. Change here to B. Okay, and I erased my slider. Need a new one. And this is going to be 26. B is 15. Change this to 15. A. Connect. And let's find the C value. It's going to be index value 19. Connect and change this to C. Now I have the information that I can read from Grasshopper, and I will calculate the X value. Let's see here. Where we go to math and square B square. Actually, we need length first. Length. We have a B square, then we need 100 minus C, and then square. 100. We need the length as well. b square minus, I can copy this one, b square minus this value and root of this, square root. And that's our path, our calculated path. Let's read the information. I think I will flatten this one as well. And let's see, I need a new element parameter, and I will connect this column to input value. I need the name of the parameter. The name is, I think, if I remember correctly, L path calc. Okay. And the values here. And we also need angle of the joints. Something is wrong actually, because this one is right, it cuts through the whole stick, but this one doesn't cut through the whole stick. I don't know why. I have to check this one. I have to check that first. It should be bigger than 100 millimeters, but it's 49, so something is wrong here. Yeah, I know now. The path is A plus this value, not only this value. Let's see, we go to math and addition. A plus this value is the length of the path, the calculated path. And now it's correct, I think. Should be correct. Let's see the result. A. Yeah, I need the length of the line. Length. Connect the length of the line to this addition component. Let's see. And now it's correct. I flattened this alt value. Delete. I have the constructed path. And now I need the angle. It's a lot of code in order to construct this path, but that's how it is. The last one is the angle, and angle we have under vectors. Angle, and the angle is between this A line and between this line that we already have since before. Go to Revit, menu element, element parameter. The name of the parameter is A1. I will copy the name. And the values. Let's take this. Now it's correct. So that's all. And we have the information about the reporting parameter, the information about the length of this line, 8.4, and the next one is 132.9. The last thing I'm going to do, I'm going to add the information about the position of the sticks. What I mean is this stick is going to have the position number 1, the next one is going to have the position number 2, the position number 3, and so on. I will have that as a text parameter. And let's go to this last stick that we worked with. That's this one, and we go to family types and properties. These are our parameters, and all these parameters are dimensions. We will create a new text parameter. We will also have text parameter as shared parameter, instance level, select, edit, new. And here, instead of length, we are going to choose text. I call this parameter position. choose the position parameter. Okay, yes, and now I have this text parameter. Save and load into project. And I will add that parameter to all my family types. Properties, family types, new instance, shared parameter select. Now it's defined, we just choose it. And load into project. Echinoidea, okay. Override the existing version. Close all previous families. This is stick 3. I add the text parameter here as well. Load into project. Close. And I have one more family type. I think that's this big group that we made using extrusion. Save and load into project. Let's go to the first stick and add the position 1. We do the same way as we did before. Element parameter, connect to the column. The name of the parameter is position. And let's see. Now we have the information about the position. Let's go to the next two sticks. Copy this. And here I have only one column. I will change this to 2. The next stick. Let's go to the next stick and connect this column to this input value. Change this to 3. Now we take care of the next 2 sticks, and this is going to be different. And you will understand why we do this in Grasshopper instead of doing that manually in Revit. Instead of this panel, I'm going to do like this for the rest of the sticks. First of all, I connect this column to this input value. These columns to this input value. The name is correct, the position is correct, and now we will use series component, and here we will start with the position 3 and we will increase the number with 1. And we have only 2 sticks here, so I can right click and write 2. And let's see, the position of this stick is 4 and the position of this stick is 3. We started with 3. We should have 4 instead. We should start with 4 and increase by 1 because 3 is the previous one. And let's see now. This is 5 and this is 4. So I need to reverse the list. Go to list and reverse list. Now it should be correct. This should be 4 and this one should be 5. Yeah, that's correct. Now I copied this. Actually, I copy only this. Okay, and go to this big group that has 35 components. Let's take the list length component and connect the list length to this count input value. This last stick that we worked with has the position 5. And the next stick is going to start with a position 6. We will increase by 1 and we have 35 components. And I need element parameter component. I will connect it to this column, the name and values. And let's see if it works. 1, 2, 3, 4, 5, 6, 7, no. I think I will just write here 35. Now it works. We had to have the same kind of information for the columns and for this series output value. And let's see here. This is position 40 and it should be 6. I don't think I need to reverse the list in this case. Let's recompute. The reverse list doesn't reverse the values for some reason. Now I understand why. Now it reverses. And let's see. Now it works. 6, 7, 8. We need one group actually. We had to flatten both this series component and this element component. This reverse list doesn't work on individual objects, only on the group, obviously. That's it. Now I have all the information I want for my schedule, and now I will make a schedule. I don't need Rhino and Grasshopper anymore because I have all the information for my schedules, and my schedules I'm going to give to carpenters so that they can produce those joints according to the information on the schedules and legends. I close Grasshopper, I close Rhino as well, and schedules and legends. We go to view and schedules, schedules and quantities, columns, okay. And we choose parameters that we want to show in our schedules. That's going to be A1. This is our angle. Then we want cutting length. Then we want the position of the joint, L1. We want L joint 1, L joint 2. We don't want to show calculated path, because the carpenters, they don't need that information in order to produce the joints. Let's see, I think we have the position also, position here. Yeah, that's it, I think. Okay, here's our schedule. And basically, I think I want to add type, family type as well. Family and type, okay. Maybe only type, family, only family. So, yes, and now we have all the information. And let's see, if we go to sheet, I need a new sheet. I take this A1 metric and I will put my schedule. I will call this schedule for row 1. Row 1. Let's go to my sheet, and here is my schedule for row 1. I'm not going to rearrange anything. Just now I'm going to put, for instance, 3D view. Here is my 3D view. I will turn off the levels. We could go to legends as well. Okay, and here we can sketch the family types, and we go to insert. Let's see, we can insert family types. I think it was a long time ago I did this. I think that's it. Yes, that's correct. And we will choose back view. We can have stick tool and show the back view. Yes, but we don't see the joint, so that's why we need to sketch it using detail line. I can take 3 as well. If I take front view, maybe you can see. Now we see the joints. And stick 4. It would be nice if all of these sticks had the same height. We can go to family types and change the height in the family, but I think I will do that later. Now I just want to show you basic. The problem is we cannot snap to the joints, so I think we need to sketch them anyway. I can change the view to back view, and then I sketch joints with detailed lines, and then I can add dimensions. If I go here to wireframe, it's mirrored, of course. Let's see what we can do. Architecture, annotate. We go to annotate, and here we will use detail line. And change the view to shaded. And now I have my joint here, and I do the same thing for other sticks. I create the joints and dimensions. Let's see. Now I can snap, and here as well, and the angle. And this one I'm going to change. I will replace this with text. I call this L1. Okay, this is going to be A1. And this is going to be L joint 1, I think. I do the rest on my own. Well, actually, I can do this one as well. Go to annotate, detail line. I call this one as well L1. Then we have this parameter that we call L joint 2, I think. We will replace the value with the text L joint 2. And we have the angle as well. With these two. Then we have the cutting length as well. Let's see. And the same thing for this one. And let's go to my sheet. I place legends on the sheet as well. Change the scale. Let's see if 1 to 10 is better. I can change the scale to 1:20. That's it. Here are my legends. I'm going to finish my legends on my own, and you can do that on your own as well. I'm not going to record the work with the rest of the legends, and I will just show you the result at the end of this tutorial. I think now you know enough and can move the information about the sticks and the joints from Grasshopper to Revit and to produce the production drawings. That's all for now, and thanks for watching.